The overall goal of the following experiment is to simulate natural chimneys precipitated at submarine hydrothermal vents of early Earth using chemical garden experiments to generate the self-assembling structures on a small scale. This is achieved by first preparing two solutions. One solution simulates the composition of early Earth seawater, and one solution simulates an alkaline hydrothermal fluid produced by water-rock reactions. Next, an apparatus is set up so that the hydrothermal-like fluid can be injected into a reservoir of the simulated ocean under an anoxic atmosphere. As a third step, electrodes are set up to measure the voltage between hydrothermal and ocean solutions during the injection. Finally, the hydrothermal-like solution is slowly injected into the base of a vial containing the simulated ocean solution, mimicking the natural seepage of vent fluid out of the ocean crust and into the surrounding seawater. The results show that a mineral precipitate forms at the interface of the ocean and hydrothermal solutions, and this develops into a self-assembling chemical garden structure resembling a natural hydrothermal chimney.
Submarine hydrothermal chimneys are just like natural chemical gardens. They were generated, we think, on Earth about 4.4 billion years ago, and they're made of iron sulfides and iron hydroxides, to the most part, with a little bit of silica, and they behave like a skin. They're generated where alkaline solutions come up into the ocean, which is somewhat acidic, and at the interface between the two, they precipitate these minerals, as I say, looking rather like a skin. In fact, one could compare them to life as we know it today, and that is, life tends to have an alkaline interior, as we do, for example, and it tends to rather like acidic exteriors. I mean, I can say flippantly perhaps that we like a pH shampoo.